Hi everyone, welcome back to the channel. In today's video, we're going to explore some amazing projects that combine 3D printing with electronics. So, let's jump right in and get started with number 8. Mech Ninja created an impressive dual-mode quadcopter that not only flies like a drone, but also drives like a tank. He 3D printed the chassis using PLA, ensuring a strong yet lightweight frame. The chassis design was crucial, allowing for precise mounting of the components and durability during operation. The quadcopter is equipped with 4 brushless motors, each fitted with a propeller at the edges, controlled by an electronic speed controller. These motors provide the lift and maneuverability needed for flight. Additionally, 4-geared DC motors are mounted at the corners, controlled by an L298N motor driver. These motors, combined with a pulley system, drive the track belts that enable the bot to move on the ground like a tank. The overall design is simple yet effective, making this dual-mode quadcopter a good project to try. Number 7. If you're a fan of mini RC toys, then Professor Boots has a treat for you with his DIY guide to building a mini dump truck. He aimed to give the truck a cute, appealing look, so he paid extra attention to the wheels and the dump bed while designing the 2D model. The first 3D printed base holds the custom PCB, which houses all the electronics. Once the base was ready, he added the drive system. He opted for a 2-wheel drive setup, where the rear wheels are powered by a DC-geared motor. The front wheels are connected to a steering linkage controlled by a servo motor, allowing the truck to turn smoothly. The tires were also 3D printed from a flexible material, but they initially lacked enough traction. To solve this, he added rubber rings around them, transforming the truck into an off-roading beast. After attaching the dump bed, his RC truck was ready to roll. Number 6. Now, let's dive into building a fully functional CyberDeck with Carter. All you need is a display, a keyboard, a single-board computer, and a few 3D printed parts. Carter 3D printed the case in 2 main parts: the base plate, which holds the keyboard, and the top plate, which houses the SBC, a USB hub, a power button, and an ultra-wide screen. He secured these 2 plates using double-sided tape, which proved strong enough to keep everything in place. To add an extra feature, Carter included 2 notches at the back of the top plate to hold a second screen, enhancing the build's versatility. The result is a simple, power-efficient CyberDeck capable of running different operating systems. Number 5. You've probably seen those satisfying GIFs on your phone, and Jay was inspired by one to build a looping ball track. At first glance, it might look like a store-bought product, but this project is entirely DIY. The ball continuously travels in a loop, moving up and down in a mesmerizing cycle. 2 key mechanisms make this possible: a lifting mechanism that raises and lowers the track, creating the path for the ball, and a pushing mechanism that keeps the ball on track, ensuring it never falls off. Jay used a gear train to synchronize these movements perfectly. Though he faced some challenges while building it, he solved them easily. Once set in motion, the result is truly captivating. Number 4. Let's look how the Coders Cafe team is innovating to assist individuals with speech impairments in communicating more effectively. They've developed a wearable device in the form of spectacles that can detect hand symbols and translate them into audible speech in real time. The spectacle's frame is 3D printed from PLA filament. While the design may not prioritize ergonomics, it does have an appealing aesthetic. A small Pi camera is embedded at the center of the frame, capturing hand gestures. These gestures are then processed through a machine learning model, which identifies the symbols and converts them into spoken words via a speaker. This project is truly amazing, offering a practical solution to a real-life problem. Number 3. If you've ever wondered how a jet engine looks from the inside, Chris's 3D printed replica will give you a clear understanding. He started with original design files that were a bit larger than needed, so he scaled them down, printed all the parts, and precisely assembled the engine. The assembly process was time-consuming, as the complete design featured more than 50 parts, each requiring accurate alignment. Once assembled, Chris added a DC motor and a custom PCB that includes an Arduino Portenta and a motor driver module to control the motor's speed. To fabricate the PCBs, he relied on JLC PCB. They provided him with high-quality PCBs at a lower cost and, most important, an on-time delivery. Their simple ordering process and extensive customization options provide better control over design specifications and ensure optimal production standards. They offer 5 PCBs of up to 4 layers for just $2 with a build time of 24 hours. You can find more details about their services in the description. Number 2, believe it or not, this Raspberry Pi case was designed by AI. Michael, who loves creating custom cases for Raspberry Pi, was intrigued by this AI-designed case and decided to replicate it himself. He 3D printed the case components individually using black and white PLA. The design consists of 2 main sections: the lower section, or base plate, which houses the Raspberry Pi, and a cooling fan. To accommodate the fan, Michael included a 40mm cutout in the design. The upper part of the case features acrylic cutouts with a string of blue LEDs attached to them. The tiny acrylic pieces are stacked together, and when the LEDs light up, they give the entire case a striking appearance. Number 1. When working on multiple computers, we've all experienced the challenge of adjusting to different environments. To solve this issue, Salim created a tiny input device that could be plugged into any computer, simplifying navigation and making his work easier. This space mouse is equipped with a magnetometer, capable of detecting magnetic motion in 3 directions. Salim mounted it on a spring system, allowing for smooth, precise turning. He then mapped the magnetic motions to correspond with mouse movements and keyboard actions. After adding 2 push buttons to the prototype, he 3D printed a custom case for the project. Salim printed the base plate with only 5% infill, then added steel balls in the gaps before printing the final layer. This added weight and provided extra stability to the mouse. He finished the printed surface by sanding, polishing, and painting it for a smooth, professional look. Once assembled, the space mouse was ready, and seeing it in action was truly impressive. Which one of these 3D printed projects you love the most? Tell us in the comments. Make sure to hit the like and subscribe button for more such amazing videos. See you soon. Goodbye.